Now, the last day we started talking about automated testing, and I want to continue on with that today. It's a topic we'll come back to on a number of occasions. So I think after today we'll move on to another area called version control, but then I'll come back to automated testing in a couple of weeks' time, and we'll come back to it a third time as well towards the end of the module. So you'll have enough of it by then, I guess, but let's see. Now I've made a small few changes to the slides that we started looking at the last day. So if you did download them, you might want to download them again if you're in the habit of doing that. So I'm going to pick up the story here, automated unit testing. So we're focusing on testing units within our code base. Typically that is either a class, or if you're not using classes, then we're talking about a function, really. We're down to that level. But a number of the kind of principles that I'll talk about in this lecture will apply whether you're testing units or doing system testing or integration testing or API testing. Some of the same principles reappear. The context for our discussion is this catalog mini project that you saw in last week's lab, and effectively there's really only one class that we want to test, but that's fine. What you did in last week's lab was you tried writing your own custom script file as a way of testing the catalog class. And I think we'd kind of agree that it's not a very pleasant experience, because the custom script was very long-winded and quite repetitive. If I just bring it up for a second. Do I have it here, maybe? It looked something like this, and it's really long and unwieldy and hard to maintain if your class was being modified, then trying to find where in your test script you should update. It's not great, really. And it was all this, we had to kind of repeatedly do this kind of stuff, create. Let's see, can I find it? Effectively this kind of stuff here where we're constantly, why can't I find it? I'm looking for something in particular. Okay, here we go. Like where we're constantly creating a blank catalog, then adding products to it. We have to keep repeating that stuff over and over again in our script. Now I know we could refactor this script and put that into a function and call that function. Yeah, that'd help, but it's as well, the only way we kind of test whether our target function worked or not is by means of, these kind of if statements, checking to see whether the result that came back from the target method was what we expected. That line that I've highlighted there, what we would say is that what we're doing there is kind of checking our expectation about the target, what we expected the target to return back to us. And that term, expectation, is a term that we use in relation to automated testing. Either way, there has to be a better way. And the better way is to use what's called a testing framework. Use some sort of testing framework. So there are unit testing frameworks pretty much for every language out there, and I'm just mentioning some of them here. We're concerned with JavaScript. One of the testing frameworks, probably one of the original ones, is one called Mocha. There are newer ones, if I'm to be honest. There's one called Jest, which is quite popular in the industry. But if you looked at two or more testing frameworks across different languages or within the same language, you'd find that they all follow the same kind of style. So, looking at Mocha is fine for us, because even if you did want to use another testing framework in another related to your project or whatever, you'd find that what you learned from Mocha you could reuse in that other framework that you chose to use. And what these testing frameworks, their characteristics are quite similar, as I was saying. What they do is they impose a structure on your testing code, and we'll see that in a moment. They provide a way of expressing test outcomes or expectations. There's that word I used there a moment ago. Rather than kind of if-else statements, which are fine, but they're pretty old school. We'll see that there are cleaner ways of expressing expectations provided by the framework. There's flexible ways of running your tests. When we use the custom approach, all we could do is run all of the tests. We'd no other option. But it would be nice if we had the option of only running some tests on certain occasions. So we had all those benefits anyway. So we're going to focus in on this framework called Mocha. And I'm saying it provides an execution environment for automated JavaScript tests. That's fine. Now, in the previous slide there, I said that these testing frameworks, they force you to structure your testing code. And in the case of Mocha and many other frameworks, they follow this structure here. So what we'll see now in a moment is we use these what are called describe blocks. That's one of the main structuring constructs available to us. We use describe blocks. There are also what are called it blocks. It blocks tend to appear inside describe blocks. And the third construct are what are called hooks. And there are two types of hooks, before hooks and after hooks. So they're the fundamental constructs. Here, then I'm telling you how they're actually used. So the way you use these constructs is each test case is wrapped inside an it block. A test case is effectively one given when then pattern that I talked about the last day. So each test case, you encode that, or you wrap that inside one of these it blocks. Then if you've got a group of it blocks that are kind of related, so for example, if you've got a group of test cases associated with one method of a class, of a target class, then you would group those it blocks inside a describe block. And you may have quite a number of test cases for one particular method. If you had maybe 10 of them, then it would be nice if we could break that 10 up into subgroups. So the way we express that in our code is we would have describe blocks inside a describe block, so we can nest them, which is kind of what I'm saying here. And finally, from the hooks point of view, where hooks come into play is a hook allows you to place code that you want to have executed before each it block. So that would be a bit like creating our blank catalog and adding products to it, as you see. So that's in English anyway. That's how these are the constructs. This is how we use them. And before I show you an illustration of that, as well as using Mocha, we're going to use a library called, well, I pronounce it Chai anyway. And Chai is a library that we use to express our expectations, how we state what we expect our target to return as a response. Okay, so this is a generic, but still it's a good illustration of the typical type of code now that you will be writing in this week's lab, and you'll be writing it later on as well when we revisit the testing topic. So here's my outer describe block. It takes a string as an argument, and inside the string, you essentially put some sort of label on the target that this script is testing. So that might be just the name of the class, but it is a string, so it's quite flexible. Now, I always say to students that this coding style initially it's quite daunting looking because effectively it's using callbacks all over the place, and that can be off-putting initially, but after a while you just you don't really see the callbacks. All you see excuse me, is the code that's more concerned with testing. So anyway, we have a describe block. I've got a before hook here. I'm just going to skip over that for a second. I've got an inner describe block. So in this inner describe block, the first argument would typically be, let's say, a method of this class. So this describe block here, which begins here and ends, let's say, down here, that describe block will contain all of the tests associated with whatever method you mentioned here. And assuming that there are going to be many methods in my target class, then I'm going to have other describe blocks down here for the other methods. Within a describe block, eventually I get to my it blocks. The it block has the first parameter is also a string, and it's in there that you might express in English the expectation associated with this test case. We'll see examples of that in a while. And then inside the it block, eventually in here is where we get to invoke the particular method of my target class that I'm testing. And it's also where I would make statements about what I expect the response back from that target method to be. So in terms of my given, when, then construct, the given stuff tends to appear, if I go back to here to my before hook, well, before I do that, the before hook, where does that play a role? The idea is that any code that you put in here is going to be executed before the code inside an it block. And it's going to be executed before each it block. Presumably, I'm going to have other it blocks here within this describe. And so whatever code I've put in here, that's going to execute first before each of the it blocks execute. So again, so the flow of execution would be the code here executes, then the code here executes, the code here executes again, then the code inside the next it block executes. This code executes yet again. The code inside the next third it block executes, and on it goes. So the code that you put inside the before each, that executes before each it block. So I've just paused for a second there. I've just realized there's a typo there. Isn't that terrible? Just give me 1 second and I'll fix the typo. Well, what I'll just tell you is, right, the typo is there. I was doing cutting and pasting, obviously. This whole thing here, that should be just before each. You can see the bit here at the end. So I don't know where that came from. So it should just be before each. Sorry about that. I'm just going to scribble all of that if I can. This is how Mocha forces us to structure our code. And as I said, pretty much every unit testing framework follows this kind of style. So maybe I could just flip over to VS Code. So what you'll find yourself doing in this week's lab is, again, we're using our catalog project. Forget about these two classes, they're not relevant. I have my products class, which is the same as before. I have my product catalog, which you're now familiar with from last week. So again, same methods pretty much. And where's my test? Here's my test script, and this is, you'll kind of build this up as you go through the lab. Okay, I've got some imports at the start, but here I've got my describe block, and I'm testing the catalog class. I've got a before each block, and that's where I'm creating an empty catalog and just adding some products to it. So that's kind of my setup before each test. And then I've got a describe block, an inner describe block for each method associated with my catalog. So it looks like I'm, first of all, testing the find product by ID. Here's the it block. I'll come back to this in a second, what you should put in here. But here I'm invoking my target method. Here's the result that comes back. And I haven't spoken about it yet, but this line here is where the chai library comes in, where I'm expressing what I expect results to contain. Got another it block associated with the same method. So it looks like there are two test cases that I need to do on the find product by ID, whereas if I scroll down a bit, here's the check reorder, and it has quite a lot more going on. It's got a number of it blocks because it's a bigger method, therefore there's more testing that I need to do. There are more kind of test cases. And so in terms of that before each, which I kind of stumbled over there, the before each block, this piece of code here, that's going to execute before each it block right throughout this script. Just some terminology, some of which I've used already in this whole area. When we talk about the target, that's essentially the piece of source code that you are testing. So in our case, that would be the catalog class and maybe the methods within that class. A target's test code is comprised of test cases. So essentially each it block there, we would call a test case. And going back to our given when then, a test case, each test case is related to one given when then statement, so which we call our user stories. So roughly each it block relates to one user story, which is one given when then text. The entire set of tests for an application is called a test suite. Okay, so that's just terminology. Target, test cases, test suite. Now, here are some principles that you should apply when you're doing unit testing and, in fact, doing all kinds of testing, whether it be system testing, API testing, end-to-end testing. Number one is the test case isolation principle. So kind of relating it to our actual testing code, we want each it block's execution to be independent of other it blocks execution. We don't want any kind of overflow from one it blocks execution into the next it blocks execution. And the way we achieve that isolation is through the before each, because essentially before each creates the context for each it block. And given that I've told you the before each code executes before each it block, that means we create the same context for each it block, and it's kind of refreshed before each it block. And that kind of guarantees our isolation principle. That's how we achieve our isolation principle. Second principle says that the test target's state as well as the response should be tested. Now, this is something that people find not so much difficult to understand. It is straightforward enough, but they forget to apply the principle. The response is, if we just talk about our catalog class and we're testing a particular method, the response is what the method returned. But when I talk about, we should also test the state. The state in the case of the catalog is the array of products. State always refers to kind of data. So just because a method returns the right response, that doesn't necessarily mean that it has made the correct updates to whatever state is relevant to it. Now, in the case of the catalog, as I said, the state is just one variable, which is that array of products, but it could be larger than that. And so we would also need to ensure that whatever method we're testing, it does make the correct change to the target's state. We need to remember that. So I'm saying a test expectation should be focused on, number one, does the target return the correct result or response? And number two, did it make the correct update to the target state? Some methods don't change the state, and that's fine, so you can ignore it. But other methods are intended to change the state, and so you need to ensure that it does do that, as well as returning a response. Principle number 3, the silent principle. Really all we're saying there is when we run our tests, we want to be told in as straightforward and clear a way as possible as to whether our test passed or failed. We don't want any other extraneous output coming from our tests. And what that really means is don't have console.logs scattered all over your test code. You may need to do that when you're doing debugging, but certainly when you've finished your testing and you're happy with the test that you wrote, you should remove any extra console logs so that there's no extra output being generated when you run your tests. And the final principle is have informative test documentation. Now, what do I mean by test documentation? Well, in the case of Mocha, this is what we mean by the test documentation. These should be very clear about what they are concerned with. Now, it's straightforward enough for, let's say, the outer describe block. You would just have the class name. That's not too complicated. For the inner describe blocks, more than likely, each inner describe block is focused on a particular method. So just have the method name. But in the it blocks, what you should be expressing here in a succinct way is what you expect the outcome of the test case to be, whether that be it should return response X and change the state to Y. Express that in very kind of short, succinct way, and in a way that's informative to the person that's running your tests. Because if I go back, actually, here's my test case, my test code, and you can see here in the it blocks, I'm saying what should happen for each test case. Yeah, you can see all of them there, and you can look at these later on yourselves. Now, it turns out it's this documentation, that's what's outputted when we run our tests. So if I actually run it, I actually did it there earlier on. Let's do it again. So This was the first describe block. That was its text, the first parameter. The inner describe blocks produce this output. And this output here is coming from the it blocks. And so this is telling me in very simple terms, look, there's a little tick mark beside each one that passed. So it looks like all of my tests pass. And that's really all I need to know. So it's the it blocks that you need to be careful about, making sure that you express clearly to other people what the purpose and expectation of the particular test case is. Now, the question always arises, how much testing do I have to do? Do I just keep writing more and more tests? And clearly the answer to that is no, you shouldn't. There are, what I'm trying to give you here are some guidelines as to when you can decide for yourself that, yes, I have now fully tested a particular target and I don't need to do any more testing, because any other testing that you do is really unnecessary, because you're essentially testing the same thing over and over again. So I'm saying there are three types of scenarios that you need to consider for the particular target method, let's say, that you are testing. First of all, you've got to ensure that you cover what are called the normal cases for that target method. Now, the normal cases means that the target's pre-test state, in other words, that array of products in the case of the catalog, the target's pre-test state is normal. I guess that would mean that our array of products has some product objects in it, and that the parameters to the target method are normal. They're just regular values. Now, everybody is kind of going to get that right. Everybody tends to do their normal testing or write normal test cases. They do that well. So let's just move on to scenario number 2. You should also obviously have error test cases. And the error test cases are really those related to any exception throwing part of your code. So if your target method throws an exception at some stage, you've actually built it into the code, and we did that in some of the methods of the catalog class the last day, then you should write a test that forces the target to throw that exception, so that you can be satisfied that the exception handling part of your target method is actually working the way it should be. And that typically means that maybe there's the target's inputs are invalid, or and the OR case is something that people kind of can forget, or that some of the input may cause the internal state of the target to move to a state that it shouldn't be in. So maybe that might be removing all of the products from the catalog, or if that makes sense. Okay, that's the error handling side of your target. And the third scenario, and this is equally one that people have difficulty with, it's called different things, but it's often referred to as boundary testing or edge testing or corner case testing. And what we're getting at there is when the inputs are just on their limits. Now, some target methods won't have any boundary cases, and that's fine if they don't. But you've got to look at the parameters of the target method And if the specification, and it always comes back to the specification for that target method, if this specification mentions anything about upper or lower limits associated with a particular parameter, then you should have a test case which tries to pass a value for that parameter that's just on that limit. So that's really what you're testing for there, is that presumably inside in the target method, you've got some sort of if statement, which is checking to see if the input parameter is outside some boundaries. And maybe you throw an exception if it does, or you do something non-standard if it does. Well, if that code is in your target method, then you better have a test case which forces that statement to be true in one case and false in another. Now, that's what we're talking about here. This is what we mean by boundary case testing. Boundary case testing may also relate to the internal state. There may be some, and again, if it's mentioned in the specification, if it's not, you don't try and dream these things up. If it's not mentioned in the specification, then you just ignore them. But for example, for the catalog, there may be a statement in the specification for the catalog class that, let's say, the array of products should never be lower than 3 entries, let's say, just off the top of my head. We should never allow the catalog to go lower than, to have fewer than 3 products within it. And so you would try and design a test case which, let's say, would initialize the state of the catalog to have just 3 products in it. And then we try and invoke the remove product method, which would cause my internal state to change to an invalid state. And of course, my remove product shouldn't allow that if I have programmed it properly. So that's an example of what we mean by boundary cases. And as I said, everybody gets this. Most people would get this as well. This is the one that people, don't think enough about and reflect on. But as I've mentioned there once or twice already, you don't try and dream these things up. It's only if the specification has references that would trigger the need for boundary testing and error testing. Because if the specification talks about it, then that means it should appear in the implementation of the target. And if it appears in the implementation, then we should test it. Now, I mentioned the child library there once or twice. The child library, if I go back to here, the child library is where, this part comes in, where we try and express our expectation about A, the response that came back from the target, and or B, the state of the target after we've invoked the particular method that we're testing. And rather than using if-else statements, which is what we did in the custom script, this is where the child library comes in. It allows us to express those things using a much nicer kind of syntax. So it's used with Mocha. It's separate from Mocha. Mocha does have some expectation part to it, all right, but most people don't use it. They use a third-party library instead, and Chai is by far and away the most popular third-party library for this. And okay, I'm saying it enables a fluent coding style for expressing expectations. So this is actually valid kind of JavaScript code. And the way you would interpret it is, if let's assume result here is the response that came back from our target method. And so what this statement is stating, and it's almost English-like, we're stating that we expect the result to contain the string product 2. So maybe the target method is meant to, maybe you give it a product ID and it gives you back the product's name, right? The second one here, we expect results to be undefined. So maybe some method that you're testing in certain scenarios, it should return the undefined value. And so you would write a test for that particular scenario. And how do we then check that the method did return the undefined value? Okay, we could use an if statement, but this is how you would express it using the child library syntax. This one here looks like we're testing a method that returns an array of things, or maybe it's an array of product names. And so we're checking that these product names are members within this array. And another example as well. So I give you lots of examples of these now in this week's lab. So you kind of build up some knowledge of what's available to us in terms of using this child library for expressing expectations. It's a nice, I'm describing it as a fluent coding style here. Essentially what's going on here is method chaining, but and this is kind of a fuller list of all the options. Well, sorry, not all the options, many of the options that are available to us. So some of them we've seen on the previous slide, but you can do things like check that the response is greater than or equal to, less than something. If, let's say, a method returns a Boolean, if you want to check whether the Boolean is true, you can use this expression here. Maybe a method returns, in some scenarios, it returns an empty array. Well, that's what we're checking for here. Over here, we already have seen the have members. Maybe a method returns an object with some key value pairs. And here we're checking to see, does it have particular keys within that object? So there's a really long list of endless options available to you, most of which you won't get to use, but you may find if you're trying to achieve something, you look up the documentation on it and you'll find a nice way of expressing it using this child library. And we can see lots of examples of that in our sample, in our lab for this week. So usually these expectation statements are at the end of our it block. And we use the same expectation statements for checking the internal state. And there are examples of that as you work your way through this week's lab. So it's not until you play with these things that it starts to make more sense. So that'll be that'll hopefully be through at the end of this week's lab. The next and final thing I want to talk about is this notion of test-driven development. And so what test-driven development is it's a methodology for developing your source code. Okay, even though it's got test in the name, it's actually related to how you approach writing your source code, which would be your kind of catalog class in the case of the mini project that we're looking at. It's quite a difficult skill to master, and like all skills, it takes time. And I do give you an opportunity to try it in this week's lab, but you may not use it again for the remainder of the semester, but certainly it's something you should be aware of. And so the starting point for using this methodology, so it's a methodology for developing source code. The starting point is over here. And the starting point, as I've already mentioned to you before, is I've got a clear specification for a piece of code that I've been asked to write, whether that be a class or something broader than that. Doesn't matter. I've got a specification. How do I go about implementing that specification? Well, as the name of this methodology suggests, the first thing you should do is write a test. So what's suggested is you take the specification and take one part of it, one aspect of it, one piece of functionality, one capability within the specification. Let's supposing it's a class we're developing, we just take one particular method, let's say, and we write a test for one part of that method. We haven't written any source code yet. So you write a test, and it should be possible to write the test, provided you've got a clear specification as to what the objective of the particular piece of functionality is. You then, well, if there is a compilation stage, you compile your tests. There won't be in the case of JavaScript. Fix any compilation errors, that's fine. Run the test. Clearly, the test is going to fail because I haven't written the target yet. So it's just not going to work. Eventually, you then write the target source code, but you only write enough of the target source code to satisfy the particular test that you wrote up here. So you write that part of your target. That might be just a part of a particular method of the class, not the entire method, because maybe the entire method has a number of aspects to it, but you're only focused on one aspect of it. Then you run the tests, and okay, you may need to make changes to the code or make changes to the test, but you stay here until that test is now passed. So you now have implemented one test, and you implemented a small part of your original specification. If you want to, at that stage, you could make some alterations to your source code to improve the design of it, but certainly not add any new capability or functionality. That's what we call refactoring. Refactoring is changing your source code to improve its design, but not to add or remove any existing functionality. That brings us back to here. We now take another small part of our specification. Maybe it's an extension of the current method that we're working on. And you write a test for that new part that you're focusing on, and you stay within this cycle again. Brings us all the way to here. Clearly, what's going to happen now is the test that we wrote in the previous iteration, hopefully that still passes. It may not, though. You may have made changes. Well, it may not pass. Let's just leave it at that. Certainly, the new test that you've written will not pass. You now extend your source code so that both tests pass, and you stay here until you achieve that. Do some refactoring if you need to, and on it goes. So every time we go around this loop, we take another part of the specification that we haven't dealt with so far, write tests for it, then eventually write the source code for that part of the specification. And we stay in this loop until we have implemented the entire specification. So the name of this methodology is test-driven development, as in it's the tests that you're writing. That's what's driving what part of the source code you're writing at any particular time. And I introduced it to you in last week's lab, if you remember. I'm sure it may not have made a whole lot of sense back then. Hopefully it makes a little bit more sense now. And I do give you an opportunity to practice it in the lab. Well, first of all, in the lab, I give you an example of it. I take you through, I think, 3 iterations of implementing a particular method for our catalog class. And then I propose another method for the catalog class. I give you the specification for it. And I ask you to follow this TDD process. And of course, I'm a little bit mean in that I force you to commit after each iteration. So you can't just do it all in one go and then just commit and pretend that you did TDD. The Git commit history will prove to me that you did actually try it anyway to follow this TDD process. As I said, it's quite a difficult skill to master. and you certainly won't have mastered it after one exercise. But there is a lot of sense to it, in the sense that it's the specification that's driving everything. And it is possible to write tests before you write the source code. That's kind of what we're proving here. But as I've said on numerous occasions, it'll only work if your starting point is complete, i.e. you've got a full and clear specification for whatever you want to implement. Right. So in this week's lab, you will use Mocha, you'll use Chai, you will try TDD, and you'll essentially be kind of revisiting a lot of the stuff that you did in last week's lab, but now using a kind of a proper testing framework to achieve it. And you will need to submit. You'll need to submit the code to me. So essentially, you'll be submitting something like this. I'm not sure if you're familiar with package.json. Package.json is what we call it, a kind of meta a project meta configuration file, and inside it is where we specify any third-party libraries that this particular piece of code is using. And of course, as I've highlighted here, we're actually indicating that this project is using the Mocha and Chai third-party libraries. So as I mentioned in the lab, the very first thing you do I'll provide you with a zip archive, and when you unzip it and import it into VS Code, the very first thing you've got to do is run a command called npm install from the command line, and that installs, in this case, these two libraries. And the libraries, you may know all this already, but the libraries actually are stored inside in a subfolder called node modules, which you'll see up here. And so if we poked around there, we would find there's other stuff that goes in there as well. But if you looked around here, you'd find Mocha and Chai eventually somewhere down here. Right, that's it. I'm going to leave it at that for today. Next week, we're going to talk about source control. In other words, the Git tool. We'll spend about maybe 2 or 3 lectures on that. And then we'll come back to testing again, where we'll be using another testing framework, but a lot of what we've learned today will apply to that. But that testing framework is focused on what's called end-to-end testing, as opposed to unit testing. End-to-end testing is a bit like system testing. Okay, that's it. Unless there are any questions that anybody might have, I will be in touch with you tomorrow. Remember now, the lab tomorrow is online. So I'll just start it off with a quick Zoom meeting, a couple of minutes, and then I'll let you work away, and I'll be available on Slack. And if you need to talk to me one-to-one, then I'll open up a separate Zoom meeting to chat with you if you're having any problems with the lab, or if you want to chat to me about anything else related to the module.